Hey everyone, good evening. So today we are going to discuss job click aggregator, not sorry, ad click aggregator. Okay. So I hope you guys know a bit about of it, right? So basically, ad click aggregator is that there is a system, right, where ads gets clicked and you have to give a holistic view to the advertisers, right? That how many ads are getting clicked, right? So basically there are two personas. One is the advertiser who kind of puts his ads, right? And the other persona is basically uh, as the customers who are clicking the ads. So let's say you have put an ad of, let's say, some shoes, Nike shoes, Adidas shoes, right? And so what happens is Amazon has its inventory on its devices, let's say Kindle or Fire tablets or Fire TV, Alexa, right? So what happens is as many the clicks are made, right? The the advertiser is charged based on it. Okay. So that's the context about it. Okay. So our functional requirements first will that we have is basically what we want to have is we want to have a page where we basically have
Yeah,
uh,
Pratik, one more point I think you need to add is like the advertiser will be n number of advertisers. So they will create the advertisement in the platform, right? And
yes.
those advertisement will have a specific ID or whatever, and they can query to that particular advertisement and get the, all the insights like, clicks and other metrics as well.
Correct. 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 Rightly said. So basically, whenever you see an ad, right? So there are normally two things called impressions and the clicks, right? Impressions is when you see the ad, right? And click is when you actually click it, right? And then there are conversion ratios and all of that. So that's a very domain specific, right? I mean, I've worked in the past on ads like this, right? So I have a bit of fair idea, but just for you to know, for this problem is that we are going to count the clicks. Okay. So there will be multiple advertisers, right, who will be coming to the platform, who will be placing their budget, saying like, let's say this is a holiday season, I want to sell Christmas trees or something, right? Or anything of that sort, right? So then as a user comes into the system, he clicks it, and the advertiser is interested in knowing that how many clicks have how many I mean how many times my ads have been clicked, right? At what intervals, right? At what time, right? So basically the granularity that can go up till 1 minute, right? I may want to see that how many clicks did I get in 1 hour, how many clicks did I get at this particular minute, right? So basically here the granularity that I'm talking about is of 1 minute, right? So we'll
I
put this
think
in
one
the
will be the clicks, the other will be also the conversion ratio. Na? Like you
uh,
click and then how many
yes.
business.
Correct. So that is also there, but we'll keep that to be out of the scope, right? Because I mean, creating the entire system would take a lot of time, right? Because you'll have to see that okay, these many clicks were done and how many percentage of it got really converted. Okay, but for this problem is picked up for multiple reasons that I'll let you know in once we get into the deep dive, right? Because it will contain the data pipeline, right? So I'm will not go to the conversion part of it, but my intent here is to basically count or give a leverage to the advertisers that how many times the ad has been clicked, and he wants to see that on some kind of a dashboard or whatever it is. Okay. So I'll say that click counts, right? Okay. And granularity, granularity, 1 minute. Okay. And what else? And the users should be able to get redirected. Yes. Okay. User should be able to get redirected to the ad page. Okay. And yeah, simple basic thing is that the user should be able to click the ad as well. Anything else that we want to capture?
Do we also want to add a count based on some category like location?
Uh, yes, that is part of the. I know you guys are like kind of very interested in kind of covering all of those things, but I want to keep those things out of scope, right? For the moment, saying that what targeting, what category, and all of that, right? Because what I really want to cover as part of this problem is basically the data pipeline. Okay, so yes, we can definitely go into that scope of the problem as well, but for now we can little park it aside and see how these clicks, right, can be aggregated, how the data is flowing, right, how these clicks will be counted, right. That's the whole purpose of this problem actually at the moment. Yeah. So, Vivek, that was a good point, but I will just keep it out of scope, right? What was it? You said basically the category, right?
Reporting based on multiple different categories. Yeah.
Okay, reporting, basically reporting based on category. Then another point from premises was the conversion ratio, right? And we'll ignore we won't be count the impression counts, right? But impression count and the click count would be very much similar, right? It's the view count. I mean, when you view a ad, right, that's one impression of the ad. Okay, so it'll be very much the same thing. Okay. And what else? We'll leave the cross device this thing, right? So let's say I am a user and I'm logged into multiple devices, let's say Kindle or Fire Tablet or Fire TV, right? And which device, at what device level, how many ads are being seen, right? We'll also keep that to be out of scope at the moment. Okay.
Multiple clicks.
And I think
Yes,
Multiple clicks from the same user.
correct. Multiple clicks from the same user, right? Avoid multiple clicks. Avoid multiple clicks. Okay. This we can call it as idempotency. Yeah.
one thing
So
can be the success versus the failure. You click on it, then the ad loaded or something like a ad blocker and it could not load
okay.
that ratio. So you clicked, but the ad loaded or not loaded.
That will be more on the client side, right? I mean, the ad blockers and all of that, right?
Mm.
But let's keep.
But from the aggregator, we should know that what is my success or the failure scenario is.
Hmm.
But that is tricky because the client tend to talk to the server and pass up this.
Yeah, because client is just not. I mean, it
Mm.
has rendered, but the client has to some way send, or let's say we'll have to bring in the impression IDs as well into picture.
I think, Pratik, you can manage that one as part of the redirect URL. Okay, because I think you are going to be, redirect the URL from the server side, not the client side. See if you can manage that one. That's quite possible in the server side on the redirect part. If it is not redirecting, that means, you can capture that one is got failed or something as
Yeah,
part of 302. Yeah.
yeah. I mean, he said ad blocker, so I mean, it won't even let it render. So basically, but yeah, let's keep this. This is a very tricky case, right? So I mean, I feel that it will be very difficult on the server side to know. I mean, we'll have to apply something, but yeah, we'll park this. Probably some other session we can take it up. This was a very good point. Anything else?
Are we going to store some state anywhere,
State as in?
like some sort of database memory anywhere, or it will?
Yes, yes. All of this will be stored in some DB, right? Because after all, I mean, this will be served to some dashboard, right? Where all of this will be rendered. It will be available for the users to view.
Okay. So in that case, like how backdated data you want to store? Like,
Okay.
what's-
So yeah. So that means that will be part of the somewhere part of the non-functional requirement, right? And in fact, this too, right? This too will be part of the non-functional, correct? Yeah. What else? What will be the non-functional requirements? A system should be fault tolerant, right? In case of failures, right? I mean, basically, we just don't want to lose the clicks, right? Just in case our system goes down or anything of that sort, right? Our system should be able to recover from it. Correct? That's what
Yeah.
fault tolerant is. Then
Also, the scale, if you're
yeah,
talking about Christmas peak and all, there should be a scale you should to
correct.
handle.
Scale, right? In fact, what you are talking about is basically the hot partition, right?
Mm.
The celebrity problem. Okay. Ram talked about durability. Yeah. So how long do you want to store the data, right? So let's say we want to store this for what? Past 6 months. What else? Now, if I talk about the cap theorem, right? I mean, what should I value? What should I give value to? To availability or to consistency? Availability or consistency? Is it okay to lose clicks?
I think that should be okay, considering availability and partition.
But I would say availability is more important,
Yeah.
right? Because consistent, it's okay for our system to be eventually consistent, right? So it may happen that I am seeing, let's say, at this point of time, let's say 1,000 clicks, right? But what happens is there are some clicks which are flowing, and then I get them to be like, let's say 1,200 after let's say 12 hours when I see them, right? But my system should be available, right? It's okay to be eventual consistent. When I say consistency, it does not mean that I'm just kind of ignoring consistency altogether, but I'm okay to have a eventual consistency, right? What else?
So the consistency we're talking in the context of number of clicks.
Clicks, yes.
So if it is eventual consistency, the advertiser will see the not correct data.
uh yes, it may happen, right? But it at that point of time, because what is happening is, see, I mean, you have just clicked, right? If you want to see the data for the let's say past 1 minute, right? Past 1 minute may not be as accurate as it should be, maybe, right? because what happens is there can be some partial clicks which are processed, right? But there are some clicks which are still being aggregated and then pushed into the system.
Yeah, but providing a unaccuracies data to advertiser, I think okay.
Yeah. So because see, this is when you say real time, right? When you say real time, and this is also aggregation, right? Um, I mean, the difference won't be like that too much of a difference, but yes, it can happen, right? It can happen. There are few clicks which can come and then reconcile with the original data, right? Okay. So then there comes another item which is called data integrity, right? So basically we have to make sure that at least eventually, right, whatever the clicks that are done, right, the advertiser should be able to see the correct data of eventually. Okay. Anything else? Yeah. Then let's go to scale. Okay. So ideally, as part of the problem itself, right, normally in the interviews you would get to know from the interviewer. If not, then you can poke the interviewer saying that I also want to know that what scale are you supporting, and this can come from the interviewer itself, right? So we can say that, let's say we are expecting, let's say 10K clicks per second. Okay. What else? And we may want to serve how many ads, right? Let's say that's like, let's say 100 million ads, or I think that's way too large. So I will say 10 million ads at any point of time, or it can be 100 million as well, right? Because it will ultimately, the ads will be there in the system, but then it will be limited by the inventory. So just to give you a context, right, since I've worked on these systems, right? So what really happens is that there are multiple advertisers who create the ads, right? But then since the inventory is limited, right, there are multiple algorithms, right? There was something called kingpin. Okay. So what happens is, based on whoever has put what bid, right? Bid per click. So let's say if I say that I'm okay that once when a user clicks on an ad, right, I'm okay to give 10 cents, right? There is another user who says that when a user clicks on this ad, I'm okay to give away 12 cents, right? So what happens is, the advertiser who has given 12 cents per ad, right, he will be given more priority than the advertiser who was okay with 10 cents. Okay. So this was all when the ads are created into the system. Okay. So yeah. So we'll create basically a flow diagram, right? Or you can say a very high level diagram, right? It's not very accurate, but it's at a very high level. Okay. So what we are saying is, let's say this is a client, right? Right. And this is an ads DB. Okay. So now what happens is, this ad service is basically serving the ads.
There should be one on the publishing the ads.
Yes. What happens is the advertiser would be actually publishing the ad here. Okay. Okay. So through the system, right, there would be some portal on Amazon or whatever it is, right? So he would be publishing the ad from here, and then it will be placed into the DB. Just click. Yeah, I mean that's what you meant, right?
Yeah, basically the publisher eventually which will enter into the database, make the entry into the database.
Yes. So sorry, this is like, don't know why am I getting double-sided
Okay,
arrow.
you click outside first. Pratik, the arrow in the top right, which is highlighted right now, you have to remove that highlight.
This one?
No, in the top you have a drop down top right, not that side. So that has to be removed, that highlight. So you have to put your cursor outside somewhere, then click another, something in that top only, not here. Click some other arrow in that same drop down here.
Okay.
No, in that same row itself. You have multiple, in the bottom itself, you have multiple arrows. Yeah. Yeah. So now click in the box actually. No. Click somewhere outside. Yeah. See, you got it, right? So now similarly, you have to delete that one and you have to click that arrow, another arrow, which you want to select.
Sorry. Yes. Messed it up. Wait, just
The arrow is after the circle, I guess. After the circle.
one. Yeah. But somehow I just want single head.
You leave it for now. You continue, double, we will understand that.
Okay.
That's fine.
So this is basically so the advertiser will be publishing the ads to this ads DB, right? And now these ads will be served to this ad service, right? And now what happens is client, right? Somehow kind of, let's say this is a device, right? Kindle or whatever it is, right? It actually pulls on its own device, right? And it can be a browser as well. It can be a Fire tablet or whatever it is. Okay. Now, what really happens here is there will be a placement of the ad right here. And what happens is once he clicks it, right, this click will actually go to some service, which we, let's say, call it as ad processor service. Okay. Done. And then this ad will be aggregated and will be, let's say, stored in some DB. Okay. Ad aggregation, let's say. Okay. So this is a overall flow, right? What's happening, how the client is interacting, how the advertiser is publishing, right? And all of that, right? But this is not a complete thing. Yes, Ram, please go ahead.
So what do you mean by aggregation here?
Right. Aggregation in the sense, let's say, I want to know that, let's say there are 1,000 users, right? And they clicked on an ad called, let's say, ad ID one. Okay. So then what happens is I'll say that at this instant, right, I got 1,000 clicks for this ad ID, right? And for this ad ID, I got, let's say, 20, right? Let's say Nike ad or Adidas ad, or let's say any ad that is there on the, that is being shown on the client.
Okay. So aggregating based on ad ID rather than users, like
Yes,
which user
yes,
has
yes.
clicked
Based on the ad ID. Because why we are doing this is because there is one advertiser, right, who is running his own ads, right? He's interested in his own. I mean, how is that ad performing, right?
Okay. Okay.
Okay. So yeah, this is a very high level diagram. This is not in fact the high level diagram. It is just a flow, right? But now what what the advertiser would like to do is the advertiser would like to actually query this ad aggregation DB, right? And would like to know that that what I mean, how my ads have performed, right? In fact, there would be some layer here, right? Let's say what do you call it? Some presentation layer here, right, which would interact with this ad aggregation table, and the advertiser would read from here. Okay, this is the high level diagram. Okay, now see, in real time, right, all of this will be flowing at a very fast pace rate. Okay, so not like just one click is coming in, let's say 10 seconds, 20 seconds, but I mean, might be for one ad, but there are other ads as well running in the system, right? So ultimately, all of this problem will have to be solved by some kind of a data pipeline. Okay, where basically the data is coming from the client, and we are processing that data, and whatever the compute or whatever that we want to do, and then ultimately we'll store it somewhere. Okay, so since I've already talked about the data pipeline here, right? So we'll just take a pause from here, right? And we'll discuss about the data pipeline in general, right? What is this concept actually, right? Okay. So why I picked this problem is because this data pipeline thing can actually apply for a lot of other things as well, right? Where basically in real time, right, you are actually getting a lot of data, right? I mean, let's say from IoT devices or from your crawlers or anything, right, of that sort, right? And what would happen is they would bring in the data, and you will have to have some kind of processors and ingest all of the data, compute, transform, or filtering, all of those things that you'll have to do, and then ultimately put it in a way that is required by the end user, right? That end user can be some system as well, right? That can be some ML system, let's say, or can be some dashboard or whatever it is, right? Let's say if I talk about a crawler, right? So what happens? I mean, there are some crawlers, there are multiple crawlers crawling on multiple websites, right? And they are kind of scraping all of the data from the websites and giving it to some kind of a processor, right? And processor is kind of indexing or all of that, and then ultimately will be storing in some database, right? Now what happens is this is the pre-work that was required for for the searches to be faster, right? So I hope you understood what we are talking about, right? So we'll take a pause from here and then move away to data pipeline. Okay, just to give you a bit of overview. Okay. So basically, in general, right, data pipeline has multiple steps, right? Out of which the first step is always the collect, right? Then is basically ingest, right? Then is compute, okay? Then is store, okay? And then is consume. right? Can you see my other tabs as well? You can, right? Yeah. So there is a very good video by Byte blog, right? I mean, it will summarize all of this in 5 minutes, right? But I'll just reiterate the same thing, right? So what happens is this collect step, right? This collect step is basically the place where the data is coming from, right? This can be a data store, right? Or it can be a data stream, okay, which is this, right, in this particular case, right? Or let's say it can be an IoT device or whatever it is, right? So this is a data stream, right, where users are clicking, right? Or it can be some kind of a let's say application as well, right? Okay, so now let's say data application, let's say how do I say this, the AQI index, right, of Delhi, right? It is constantly throwing it, right, in every second, that what is the AQI, right? But then ultimately what the sensors or whatever they're installed in the city, right, they will show you an aggregated value, because see, AQI will not be like constant, right? I mean, let's say a car passed, or let's say there was a traffic jam, right? So let's say the AQI will be let's say 500, right? Or let's say or during some other time of the day, the AQI will be little different, right? At night, AQI will be little lower, right? In the afternoon, it will be little higher, right? So but if you say that what was the AQI of for that day, correct? So I mean, all of this will be, there is some application or there is some sensor who's actually sending all of this data, right? Or let's say you have your Fitbit devices, right? You're running, right? You're walking, right? So those Fitbit devices are actually constantly sending your steps, right? To to the further steps to aggregate them, correct? So these are the different sources basically, right? It can be a data store. When I say data store, it can come from a database as well, right? So basically data pipeline is your data can be stored in MySQL, Cassandra, or whatever database, right? You say, right? SQL, NoSQL, right? And from that we are processing the data, right? This is some user when he's clicking on something, right? Or let's say your whatever it is, right? Like let's say this client, right? So that I would call as a stream, right? Data applications, right? Your data, I mean, some application is recording it and then it is sending to the further set of steps. Okay, so these are the different categories or sources that can happen, right? Now, this is the ingest step, right? Ingest step is basically that there has to be some kind of a pipe, right? There has to be some kind of because what happens is every step, right? I mean, since there is a lot of data that is coming in, before you compute it, right, you'll have to somewhere store it, because these are the producers, right, of that data, and your compute is like the consumer of it, right? So now let's say if your consumers are not really able to make up with the pace of the data that is coming in, right, that will be a problem, correct? So there has to be a pipe in between, so which is called the ingest step, right? So here there are some what I call frameworks like Kafka or Kinesis, right? AWS Kinesis, right? So which are used at this step, right? So now at this place, right, we will have to use one of these, right, to store the data, right? And now how do you get the data from the data stores, right? It can be, let's say, the data stored into the DB, right? And what happens is, let's say there are inserts or updates, right? So what happens is that DB can actually trigger some kind of a CDC events, right? What is CDC? CDC is basically click data capture. Okay. Okay. Now what happens is, let's say any modification to the database, right? Okay. It's a concept of the database where basically what happens is, if any changes in the database happens, right, it actually emits an event, right? And those events would be captured and stored inside this Kafka or Kinesis. Oh, sorry. Sorry, chain data capture. Yeah. Chain data capture. Sorry. Yeah. It's chain data capture, right? Any change in the database, right, that will be stored inside the that will be counted as an event and will be stored into the Kafka or Kinesis. Correct. Now this is one step, right? Or not necessarily just a CDC, right? It can also happen that the data is already stored and you are doing it batch way, right? So let's say um, the data is already stored into the database and you want to uh, read the data, let's say for some date, and then process it and then stores some results, right? So from the data store it can be either through batch or CDC events, right? And anyways, this is the click streams. There are connectors, right, which will help us to put the data from these to Kafka or Kinesis. Okay. Now, the next is basically the compute. Okay. At the compute, right, there are two things. Okay. Either we can do the batch way, right, or we can do the streaming way. Okay. So when I say batch way is basically that what a batch means is you have some data there, right? You are kind of accumulating it, right? And then you are kind of taking all of that data together and then processing or computing on it. Okay. Yeah. Cool. What is stream? Stream is basically the real-time data processing. Okay. So whatever the data is coming in real time, click by click, they are kind of, or event by event, they are getting into the system, right? So some of the tools which are used for back processing are like, let's say Spark is there, okay, or Hadoop is there. Okay. Hadoop was very famous until like 2013, 15, right? But then what happens is Apache, once Spark came in, it was I mean, it had a lot of other capabilities, and it was much better than Hadoop, right? To be honest. So that is the reason, right? You will say that if you are talking about batching, I mean, a lot of people will talk about Apache Spark, right? If you're talking about streams, right, you'll have to there are multiple tools here, and you can quote Flink, one Apache Flink or Apache Storm. Okay. But Flink is a lot more popular than Storm, and there are multiple. Okay. But I think just knowing just a couple of them will be enough. Okay. Now from the interview point of view, you may have to defend yourself, saying that in which case, or you may have to quote why Spark is better than Hadoop or why Flink is better than Storm. I'll not really go deep into it, right? Even I have to check, right? But I mean, interviewer may ask you, right? Why are you using Flink and why are you not using Storm, right? So yeah, you may have to spend a couple of minutes there to let the interviewer know why you are choosing one over the other. Okay. Now, as part of data store, right? What happens is after the compute, right? You will store the data in some kind of a storage. Okay. So now see, all of this is this all of this data is massive. Okay. So now you might have heard of these concepts called data lake, right? Or data warehouse. Okay. Now, guys, sorry. I mean, probably few of you may know these, you may not, because initially all of this used to be covered as part of data engineering. But now you guys know, right? The interviewers are kind of grilling more, right? And with AI coming in, you have to know everything. Okay, there's no boundary as such, right? So that's why we are going here. Okay. So now when
So,
I say
so what happened is out of box aggregator technology we have, right? Flink and all you discussed, right? So a lot of computation, right? They do out of box, right? So here the interviewer nowadays, ask like how you can design your own, startup service and capture those aggregator logic. So that also we need to keep in mind. So if you know it, you can add, that will helpful.
I mean, Flink as a framework gives you all of that, right? I mean, it it basically has some features, right? Like you can window.
That's that's clear, Pratik. So let's take an example. Find a top case song from Spotify, right? The Flink can do in 1 second actually. But there are the data structure and algorithm we can use in our own service, like uh, hippify logic and all, right, to get out of
Correct.
get your own logic. So similarly, I'm asking here also we need to consider the alternative as well.
True. See, Flink, I mean, see, when I said aggregation here, right, there can be something else, right? There can be some filtering, right? This can be some kind of a scraping, right? All of that. I mean, Flink is not, or Flink or Storm, these are not just for aggregation. They can be for various other things, right? I mean, what kind of computation that you are doing, that completely depends on your logic inside them. Okay. So now you may just get this data and then aggregate and then send it, but you may also do some kind of transformations, right? Some data is coming and then you want to just cut short it, right? Or let's say it is coming in a very raw form and you want to like convert it to some other consumable form, right? So all of that can be done, and that is your logic that will go inside this. Yeah. So once all of this is done, this is stored under data lake or data warehouse, right? So these are very confusing terms, right? But how I remember this is basically when you say lake, right? It is a raw data, right? It is a raw data, and you can put it to, let's say, S3. Okay, one example, right? There can be other places as well, like let's say S3 or HDFS, right? So these are just file systems, right? So whatever you have kind of done the computation, you just throw it, right? That's what lake is, right? However, warehouse is something, right, which is little more organized, right? So if you have a structured data, right? If you have a structured data, then in that particular case, you have options like Snowflake. These are all from AWS. Okay, these services. So basically, this is something that was asked to me in Intuit interviews, okay, recently, right? And they had asked me to kind of design a crawl system, right? And there particularly as well, right? This complete data pipeline was asked, right? So it is worth knowing all of these terms, right? All of these steps, right? That's why I'm discussing these here. Okay. Now this is consume layer, right? Now consume layer is actually more of a presentation layer. Okay. Okay. Now what really happens is there. I mean, you can after this, right? Power BI or let's say Tableau, or and there are I kind of looked up. There is a tool called Looker, right? So this, I don't have much idea into it, but you guys can research on this. What this basically does is, I mean, it gives what do you call analysts and other people, right, to write simple queries, which basically kind of can get your data from these data sources, from these stores, either from data lake or from data warehouse. Okay. So yeah, this is important, the data pipeline. Okay, I'll just remove this data capture thing. Okay. Now we'll have to come back to this again and have some kind of a data pipeline here as well. Okay. So I'll just copy this again. please do this. Data pipeline somewhere. Okay. Guys, any questions? Anything till now that you didn't get it or have any questions, want to contribute anything?
Technically, the consume should be out of the data pipeline, right?
Which one?
The consume one, that should be
Uh-huh.
out of the data pipeline, right?
Correct. I mean, this is just a step actually, right? I mean, there's nothing concrete as such, right? I mean, yeah, you can actually
Yeah, this
say
is more like end to end, like starting
yes,
from
yes,
ingesting, collecting the data to ingesting into the database. It's all
right,
one.
right. Okay, so we'll just modify this to fit the data pipeline thing. Okay, just remove few things from here. So our add processor service, and we'll have to introduce Kinesis here. Okay, then is we'll be doing this for Flink, let's say. Okay, and then we store the we compute all of this and then store into some kind of a, I'll call this as a OLAP DB, right? I forgot to mention this, right? What this is. So guys, what happens is now here, right, at this store stage, right? Okay, there are two terms which are kind of talked about, right, in data engineering, right, which is OLAP DB and OLTP. Okay, OLAP stands for online transaction processing. Okay, sorry, OLTP stands for online transaction processing. Okay, okay, and this is for online analytical processing. Online analytical processing. Let's copy this from here. Okay, so now why these terms, right? I mean, when we have DBs, right, we can specifically talk about, right? So now what happens is, as part of data pipeline, right, data pipeline is a very general thing, right? I mean, we really don't know that the data that we are processing as part of the pipeline, right, is actually some payments data, right, some kind of transaction that we are processing, right, or we want or our data, right, is for analytical purpose, right? Correct. So normally what happens is this OLTP, right? These are normally row-based data, right? And these are normally columnar database, right? Because what happens is when you are kind of visualizing the metrics, right? You kind of refer to the columns here, right? So these are the two kind of broad categories. We'll not talk about what database it is, right? Because any columnar database can actually fit here. Okay, or in general, I mean, it's not true, but in general what happens is for OLAP DB it's the columnar database that suits better, right? And for OLTP it's the row based databases which suits better, right? So what I really did here was that I said that I will process this and then put this into some kind of a OLAP DB, right? That means what? I'll put this into some kind of a somewhere into some kind of a columnar DB, right? So it can be Cassandra or let's say BigQuery, right? So all of the DBs that we can kind of put the data into. Okay. Now what happens is the advertiser would be actually now connecting to the presentation layer, which will be some service here, and this will talk to this OLAP DB and then serve the data here, right? Now this, what is we basically are aggregating here in this DB, right? This DB basically stores our aggregated data, right? It what does it store? It will store what? Ad ID, right? The advertiser ID, right? What else? Some kind of a minute instance, right? And the click count, right? Correct. You can, or it may also be some kind of a time series DB as well, right? Where basically what we have in the primary key as the time instant. So let's say when I say time instant, meaning like it can be the time at the moment is like 10:02 p.m., right? I mean, you can convert it to multiple readable formats or whatever it is, right? But 10:02 is 1 minute, right? At that instant, how many number of counts that we have? Let's say we have 6K clicks that we got, right? At 10:03, right? What is the click count? Let's say we got just 3K, right? And so on. Correct. So that's how the data would be getting stored here. Any questions till now, guys? Okay. So I assume that we all are good, right? Prashant, any questions? Amol?
No.
Yeah. So this is a very high level diagram, right? I mean, there can be questions coming from any directions, right? Be it kinesis, be it Flink, right? So these are something that we'll have to dig deeper, right? We'll have to read through, right? That's what I can say at the moment, right? But these are kind of very much integratable services, right? I mean, go to AWS account, create kinesis, right? Just watch tutorials. How do we just send the data to it, right? All of that. And in place of this, there can be Kafka as well. Okay, if you're comfortable with Kafka, that if you have used, but specifically for streaming, right? It is Kinesis that you can use instead of Kafka. It is much more preferred, I would say. Okay. Now, I hope we have covered our click counts thing, right? Okay. Then, yeah, okay. I'll have to still talk about few things here, right? So what happens in case of Flink, right? There are few things that happens here is, right? Now when the clicks are flowing through this, right? Now what happens is Flink has some kind of a window, right? Okay. It says, let's say 60 seconds of window, right? So what happens is 60 seconds of window, what will it do is it will actually read all of those clicks, right? All of those clicks and then aggregate them and then push it to this OLAP DB. Okay. Cool. Now this is something called what do you call it? What is this called, Saman? I think aggregation window.
Tumbling window, sliding window, right?
Aggregation window. Okay.
I want to understand one thing. The Flink is pulling the data, or it is, the Kinesis is pushing the data?
No, it is Flink who's pulling the data.
Who is pulling?
Flink.
Are you sure?
Flink is pulling
I
the data. It's just a pipeline, right? What happens is this guy is pushing and this guy is pulling from here. Okay.
So when we say pull, right, so Kinesis should have some sort of storage.
Yes, yes, yes. Kinesis has some kind of a storage, right? It is very similar to Kafka. You can actually set a durability, like let's say 7 days, how long you want to set the durability and all of that. This is more of a storage only, like the way Kafka it is.
Okay.
Okay. So the way that you operate with Kafka, right? There will be some kind of a consumer threads on this, right? And there will be multiple workers in this Flink who will be processing based on the add ID. So let's say there is worker one, right? There is worker two, right? There is worker three, right? And along with this, right, there are consumer threads as well, like consumer one, consumer two, consumer three, right? So what basically these are doing is these are basically pulling those content, and then let's say if it is based on if it is add id 1, it is actually pushing it to worker 1, right? It is handing over to worker 1. If it is if c2 gets the add id 1, it will again push to worker 1, right? Because worker 1 is the one who is aggregating this, right? All of that, and this is all happening in memory. Yeah. Cool. Okay. So now this is there, and what else? We can also have some kind of a queue here as well. Okay. Because so let's say, I mean, normally what will happen is Flink can actually go and update to this OLAP DB, right? Probably there can be some kind of a worker who will go and update this DB, right? But then it may happen that there might be other processes or other pipelines or as well who are actually kind of pushing the data to this, right? So I will not get deep into it. So my point basically is, instead of directly updating the DB, right, you can have some kind of a consumer service here, and Flink can actually push all of that aggregated data into that queue, and then those consumer threads can actually pick that data from that queue and then update this whole app DB. Right? Cool. Okay. Now there is something called flushing window concept as well. Okay. Now what happens is this flash window, right? What happens is this Flink, right? What this does is, let's say instead of aggregating like and completely for 60 seconds and not updating the data, right? So what happens is, let's say the advertiser goes and sees in the current minute itself that, okay, right now the time is what? 10:08, correct? Okay. 10:08. Okay. So now what happens is, at this point of time also, he wants to see how many clicks have I received. Okay. So what happens is, there is a concept called flushing window. What Flink can do is, Flink can basically capture or aggregate the data for 10 seconds, right? And flush that into that OLAP DB, right? So what happens is, in the DB, right, what you would see is at 10:08, right? And let's say 10 second, right? You let's say see some 1K clicks. Okay. Now what happens is, in the meantime, right, at 10:08, another 10 seconds, which is 20. Okay, this is till 10 second, and then this is the difference between 10th and the 20th second, right? Another 3K clicks comes in, right? But then, since our granularity was only for 1 minute, right? So all of this would be merged, and then at 10:08, ultimately in the DB, what you would see is 4K, right? So idea of this is basically, let's say this flushing window, right? Let's say, what do I say? Let's say if you wanted a granularity, let's say of 1 hour, correct? Okay. And you are not updating your database or your presentation layer till that instant, right? Let's say I will only update the database at 11 o'clock, but that's not a right thing to do, right? I mean, I may want to know what is at I may be curious to know what is the click count at this point of time, right? So this is something which is very specific to Flink, right? It may be with Storm as well, but when you're talking about this concept, you can have this something called aggregation window, and you can talk about flushing window as well. Okay. So all this is good. Okay. Now, we had discussed about a celebrity problem, right? Um, we'll discuss all of that, and then we'll again go back to the functional, the non-functional requirements, what we have covered and what we have not. Okay. So see, if you have to scale this, right? Obviously, we'll have to increase the instances of it, right? Okay. Okay. You can probably draw multiple blocks of these, right? Okay, as such. So basically, you'll have to increase or scale at this level as well, horizontally, right? And now, how do you scale Kinesis, right? I've got these figures, right? So basically, Kinesis supports around 1,000 events per second, right? Or 1 MB per second. Okay. Now, what we had was basically 10,000 clicks per second, correct? So that means what, this won't be able to support this, correct? Now, if you want to scale this, right, we'll have to have multiple shards of this. Okay. So all of this is achievable through by scaling in AWS, right? All these are just configurations and this can scale. Okay. So if you want to support, let's say 10,000, so you'll have to at least have 10 Kinesis to have in order to store these many, what do you call, in order to able to serve 10,000 events per second. Okay. And similarly, right, Flink can also be scaled in a horizontal way, right? Now what happens is, but each worker, right, each worker will be aggregating for a given ad ID. Okay. So what happens is, you cannot give half of the clicks of a given ad to worker one and half of the clicks to worker two, right? Then again you would require some kind of a coordinator who kinds of merges those and then stores into the DB, right? So idea is basically one worker for a given ad ID, right? And this can be set of a pool of workers, right, which can pick up the ads. Yeah. So now that hot celebrity problem, right, somebody talked about, right? So let's say some ad becomes very what do you call, very popular, right? So let's say, what do I say, now this is a Christmas season, right? And some kind of candles or some kind of lights an advertiser has put, right? And everybody would be rushing to just buy those candles, right? So this problem normally is solved by kind of further partitioning it. Okay. So now what was happening is, see, all of this, right, when these shards were created, right, different shards were actually catering to different sets based on their ad IDs. Okay. And we can have some kind of a load balancer, or this service kind of takes care of it, right? To which Kinesis to push into, like, let's say there is some ad ID one, so then it will go to one particular shard only, right? Then there is, if there is an ad ID two, then it will go to that particular Kinesis only for the data, right? That's how it will be stored, right? But then what happens is, we are saying that one particular ad becomes hot partition, right? That, I mean, the Christmas ad becomes very Christmas candles ad becomes very popular, right? So what happens is, this kind of a problem normally is solved by kind of by appending another kind of integer to it. Okay. So it is again partitioning further. So let's say I add 0. Okay. So what happens is, just let me delete this. So let's say add ID 1 and I say 0. Okay. Add ID 1, 1, add ID 2, and then so on till n. Okay. Now what happens is all of this will be handled at this layer by different kinesis. Okay. It'll be all of this will be handled at this layer, right? And now what happens is Flink has to know that this is a popular ad, right? Only then it will be able to know that what I have to do is I have to actually converge all of these ad IDs and give it to a same worker. Correct? So what happens is as soon as some kind of an ad becomes popular, right? We can introduce some kind of a cache here, right? Okay. And store that ad here. Let's say ad ID 1, right? And now Flink can coordinate with this cache, right? To know that if this is a popular ad, right? Based on it, right? This kind of logic will be like segregating, right? From different kinesis, because consumers will have to know that, okay, this ad ID 1, right? That means I have to take out some prefix, this one, right? And see, and what do you call? Mm, handle all of this and then hand it over to the same worker thread, right?
So
That's
one point, Prateek. So instead of having this hard-coded format, right, we can introduce some sort of schema, JSON based, or so that Flink as a service and ad processor as a client both are following the same protocol.
yes, we can actually, right? I mean, that's a very valid point, right? I mean, let's say whatever the data that you're getting, right? So let's say it's a JSON in a JSON way, right? Let's say ad ID, and there will be other let's say click, right? Let's say this will be one event, right? Let's say, right, advertiser ID, right? Okay, ad ID, let's say 1, okay, advertiser ID, let's say some X, okay. Now you can also say that sub partition, right? Sub partition, let's say what Ram is saying, right? It can be either let's say 0, right, or some number, let's say -1 in general, or otherwise it can be from 0 to 1 to n, right? So based on it, right, the Flink would know that, okay, this is an or I mean, ideally we should not keep -1, it should be 0, and then we can start here from 1 to n. Okay, so if it is a non-zero, then we can kind of group all of them. I mean, in fact this is the right way, right? Because if you're sending a JSON, right, I mean, in case you want to change the schema later on in future as well, and if you want to add something else also, that's how normally the messages comes to these consumer threads.
In case of hot setting, right, the cache you have added for specific ID ad, right? Can you take that flow again?
Yeah. So what happens is this ad processor service, right? I mean, there are two ways. Either you whatever the data that you're sending in the in the payload, right? You kind of let the Flink know that that you have to do some kind of a what do you call aggregation at that ad ID level by the consumer threads, right? That way, or this ad processor service will have to make an entry into the ad cache service. I mean, some kind of a cache service, and this Flink, it checks, okay, I mean, I have consumed this message. I mean, do I really need to do
How
some
the
kind of,
Flink will come to know I will check this particular ad from the cache?
I mean, see, it is getting some ad ID, right? And ad ID 1 is basically a popular or a celebrity problem ad. This is more of a workaround, right? This was not part of the original flow.
Okay.
Right, this is only to cater this celebrity problem flow. Yeah, I mean, what Ram said, right, this is also one of the alternative that we can do. I mean, instead of having a cache altogether in the payload itself, the consumer threads get to know that, yes, okay, if this is a non-zero value, that means what, there are other clicks as well that I need to consume from other kinesis pipelines, right? And aggregate them and then send it to some particular worker. Yeah. So that's there. Okay, hot celebrity problem. Then we also said that fault tolerant, right? Now, what happens if fling goes down, right? Okay, fling can go down. Okay, so then in that particular case, Kinesis will have to store the data, right? And I mean, we can increase the durability to a certain extent, let's say 7 days or whatever it is, right? And based on it, fling can kind of pull the data from here. I mean, whenever it is down, right? Kinesis, yes, can go down, right, as well. But then similar to Kafka, right, it also can uh, recover the data and then come back, right? But in the meantime, right, what can happen is if the ad processor is actually pushing the data to Kinesis, right? And if it completely goes down, then it's a problem, right? We would lose those clicks. But I think it also Kinesis, Kafka, right? They also have this um, I mean this leader follower architecture, right? So what happens is if any leader goes down, right, then it's the peers who decides who which of the next peer would become the leader, right? We'll discuss that, right? What are the algorithms and all that, but in general you can say that yes, there may be some data loss as well at that point of time. Open for suggestions. If anything you guys can contribute, can suggest if there is a better way.
So, Pratik, in case of Flink, right, what I understood, Flink has a inbuilt, like as you were talking Flink, right? So they have a concept called checkpointing actually. So
Yeah.
that will take care of, what you were talking here. Yeah.
No. So, okay, since Shamal raised this point, right? I did not cover this in the interest of time. So there is a concept called checkpointing, right? Now, what happens is in case of checkpointing is basically what Flink has, right? Flink has apart from the in-memory storage, right? It also can connect to some kind of a persistent storage. Okay, and now what happens is let's say Flink kind of let's say it has aggregated the data for 23 hours, right? And then it goes down, correct? Then what happens is it will have to again re-aggregate all of that data to that point, right? So what happens is whatever the aggregation is done, right, at checkpoints, right? Let's say 1 hour, 2 hour, 3 hour, right? It keeps on storing, right? All of that data in some kind of a persistent storage, right? So just in case it goes down, right? Or anything that happens to it, right? It doesn't have to redo the everything from the beginning, right? So these are some very important points, right? The aggregation window, right? I'll just quickly repeat this. It's basically the time where you're kind of aggregating, right? Flushing window is basically sub part of aggregation window where basically you are kind of flushing partial data, right? Checkpoint is basically you're kind of having your own persistent storage, right? So that just in case of any failures or anything, right, you are able to continue from that checkpoint again. Yeah. Okay, cool. Now, sorry, we are a little over time, but this is very interesting. Okay, another 15 minutes. Okay. Now, what happens is we discussed about what as the data pipeline, right? There are streaming and there are batch processing as well, right? Now, what happens is there are at times some errors also that can happen, right? While stream processing. Okay, so now what we can basically do here is we can also take another flow, right? Because one of the points that we had discussed here as part of our non-functional requirements as well was data integrity, right? Our data should not be kind of lost. Those clicks are very important for us, right? I mean, I may not see the correct data now, but then let's say at some later point of time, at the end of the day, I should be able to see the correct data. That's what my expectation is. Okay. So now what we'll basically do here is, we'll basically take another system, right? Another flow, let's say S3, right? And what happens is we can actually push all of this data through some kind of a consumer service, right? To S3 as well, right? So basically Flink is also consuming the message, and from some kind of a consumer service, right? I'm also consume raw clicks. Right? So what am I doing is I'm consuming these raw clicks and then dumping it to S3 here. Okay. Now I can also have another system, another batch processing job, let's say Spark, okay, which does the computation, right? And it is slower. Okay, this was very fast. This was a speedy path, right? And this is slower, right? And what this does is this basically kind of does all of this, right? And what let's say some kind of an intermediate storage here, right? Okay. Okay. And then we can have some kind of a reconciliation service. Right? Now, or a job or whatever, right? I mean, we'll have to have, in order to trigger this, right? We'll require some kind of a cron job as well. Okay. Now, I'll talk about why am I taking this path as well. Okay. Now this reconciliation service, right, is basically connected to both, right? This and this, right? Now all of this data that is computed by the Spark job as well, right? Because what happened is, when Spark kind of consumed this S3 data, right, for that particular minute, all of the data was actually there, right? All of that clicks, right, which were, let's say for some reason did not flow, or whatever XY reason can be, right? I mean, they, let's say it is at what? It is at 10:01, right? We are computing for 10:01 click data, right? If it is of 10:01, right, I am actually, let's say, running this job at 10:30, right? So by 10:30, right, all of this click data has been dumped into this S3, right? And this, at this point of time, Spark will have all the data to act upon, right? So, and then it will compute and then store, and then this reconciliation job or a service, right, can actually compare for these instances, right? Let's say at 10:08, right, what is the data in this OLAP DB and what is the data in this store, right? This will be somewhere also in OLAP DB itself, right? I know we are duplicating this, right? But the purpose of this is that if any mistakes or anything wrong that we have done, right, or we have missed any clicks, right, this reconciliation service will go and correct it. Okay, so it will only correct when, I mean, when there is a difference, right? If they are identical, then there's no problem. And yes, we can
So,
have
instead of recon service sending that event to OLAP DB, should it not send it to Flink and say that, hey, you missed this record, now you should process this as well, so that our the flow to presentation layer remains intact with Flink. Otherwise, we are
It is, right? It is. But then see, now I ask you, right? You are busy with something else, right? You had processed multiple ad IDs, right? And now it is just a comparison of those final figures. We are not sending the remaining clicks to Flink for aggregation. It is just a comparison service.
okay. So what does it mean for presentation layer then? Like if we are sending it to OLAP DB,
Correct.
it's
What
going
does
to
it mean for the presentation layer? Yes. What may happen is like, let's say I'm looking at the data for 1008. Let's say at at the time interval of 10. Okay. So my user is basically looking at the data at 10:10, right? And he sees, let's say, that 1008, right? And the ad ID is 1, and the ad ID 1 is there, and then this is advertiser X, okay, whatever it is, okay, and the click count is, let's say, 1700, okay. Now what happens is, at 10:10, yes, it may be 1700, right? But then what happens is, let's say I look this data again at 11 o'clock, right? And I go back and I said, like, oh, it is 1700, good, I've got good clicks, right? But then let's say at 11 o'clock I come back, right? And I see that it has actually increased to 1830, 130 clicks more, right? I mean, being in ignorance, right? I mean, it's okay if I update the advertiser later on also, right? Rather than giving him the wrong data. Yes, at 11 o'clock when he comes in, he gets to see 1830. That's fine, right? That's the
Okay,
purpose.
so if he will put that, reconciliation service in one word, the streaming path we defined, right? That is optimized for, delivering the data as a low latency, right? Not absolutely correctness approach.
Correct,
So
correct.
yeah, go ahead.
Yeah. So basically, this reconciliation service will actually override that data 1730, right? We may keep as a history or whatever, right, in some kind of other database, right? That what really we got from here and this, right? So that at least we're able to figure out that what actually happened, why 1700 got converted to 1830, right? But it's better to show him the correct data, right? And based on this also, right, this is also an earning for our system, right? This is also an earning for our system, right? I mean, otherwise we would have lost what, 130 clicks, correct? Okay, so all of this is there. What else? There are two more points. One is idempotency, and there's another concept which I want to talk about is kappa architecture and lambda architecture. Okay. Now, what is kappa and suddenly how this all came in, right? So this is all related to data pipeline again. Okay. So now what happens is, what is kappa? Is it Kafka? How did it get its name and all of that? I'll kind of explain, right? So now what happens is, initially, right, it was the lambda architecture which came into the picture first, okay, or it was coined first, okay. So if we just talk about lambda architecture, lambda architecture. So if you talk about this, right, one is, I want to know the history as well first. Okay, so this was given by Nathan Mars. Okay, 2011, around Twitter, to merge slow, accurate batch processing with fast and real-time processing for big data, addressing conflict between latency and accuracy. Okay, this is very much important, right? You want to decrease the latency, right? When you're seeing the data, it uses separate batch speed and serving layers, offering a comprehensive view combining the both computed batch results and stream insights. Okay, so this is at a very high level. I'll just give you an overview, right? So basically what happens is, in this data pipeline again, right, I'll just pull this again. Okay, anyways, so what happens is this is your data. Okay, data stream, let's say. Right now what happens is the customer says that I want very low latency, right? But what happens is batch will give you a result after some time only, right? I mean, it has to wait until all of the data is kind of stored into the system, and then at particular time that batch would run, right? Correct. But the advertisers wants to know that, okay, I mean, why can't I see partial data as well, right? So what happens is this data stream, right, would pass through a batch layer as well. Okay, and it will also have a speed layer as well. Okay, okay, and then another term that you saw here was the serving layer. Okay, now this is the serving layer, right, where basically all of this, right, I mean, through this path, right, this database will be updated with serving layer, right? So this database will be updated with the computed data, right? And batch layer will also come and then recorrect the data, right? So this is what is called Lambda architecture. Okay, now this is a little complex, right? You have some kind of a batch logic, you also have a speed layer, right? But what is it really helping you with, right? It is actually helping you to give the accuracy, right? You what ultimately with this what you're getting is basically accuracy, right? This is giving you, this batch layer is actually giving you the accuracy, and this is giving you low latency, right? Ultimately what you may see is little inconsistent data, but over the time it will be consistent. You would get the accurate data, right? This is the Lambda architecture. Okay, now Kappa architecture. Okay, now what this says is, this says let's keep this simple. Okay, let's keep this simple, and this is the serving layer. What I now care is only the speedy layer. When I say speedy, it's basically the stream processing. Okay,
Is it necessary? Is it necessary to to get a accurate result, right? Always to our advertiser
yes,
or any sort of
not
use case. Hold
no,
on.
correct.
So
It
hold
yeah,
on.
sorry.
So is it necessary absolutely for for our designing to capture both the architecture to provide accurate result to advertiser or any sort of use cases? So do we need to align with both the architecture always, or is there any way to provide the accuracy result
It
in case
depends.
of this type of use cases?
It depends use case to use case basis, right? In this particular case, right, money was involved, right? Every click costs some money, correct? Every click costs some money to us,
Yeah.
correct? Now, if I
Okay.
let
So let's come out from our system design little bit, take a real discussion. Like, in case of your Amazon Kindle or maybe, YouTube advertisement and all, right? So we cannot, compromise the accuracy of the system, right? So if you were aligning these two use cases, Kappa and as well as, Lambda architecture, right? So it is definitely at the end costing a lot for the system as well as user to get the result. So is there any way to get a result in one way? That's the overall question. Yeah.
no, see, with see here, what you are kind of you are actually getting latency, right? Low latency, but lesser accuracy, right? Okay, here you're getting both, right? But then it costs you something, right? I mean, the infrastructure cost is also costing you, right? But let's say you are doing some kind of a machine learning or anything, right? You may go with this, right? You may go with this, right? Let's say a crawler system or anything, right? Even if there is slightest of the information missed out, that's okay, right? But but in this particular case, right, I think this is needed, right? So these were just terms, right? But if once you hear them, I mean, if you talk to the interviewer, right, I mean, at least he'll get to know that yes, you have an idea of these system, of these, at least the terms, right? You understand what is the difference between them, right? So in this particular case, what we are doing is we are going with the Lambda architecture. You can say that, I mean, if you I mean, if you're a startup or anything, right, or if your use case is a little different, right, you can get rid of this piece. Okay. One last thing is basically idempotency. Now, any ideas there? I just want to cover it again. So
The ad
see,
ID can be a unique identifier where we can
okay,
just take the unique ones, right?
right, we
So
can do the unique ones. Correct. Now,
So ad ID in combination of user ID, session ID, because different user can click on the same ad at multiple places.
mhm, yeah,
So only ad ID should not be sufficient, I think.
correct. Right, because ad ID there can be hundreds of users here, right? Okay, so now
Even in case of, you are maintaining the session ID, right? I can take that URL of the advertiser and put outside of the system
yes, so see,
explicitly out of the session as well. Yeah.
correct. Yes. So now user ID, somebody said ad ID, right? Combination of both, right? But I can click two ads from two different places as well, right? At two time instances as well, right? Like let's say if I've clicked on that ad, right? I mean, I may click that ad from other device as well. Nobody is stopping me, right? Let's say I've clicked somewhere, and then my kid is playing with the Kindle, and then he clicks on that ad, and that's a valid ad, right? Those are two different devices. Then you need a combination of the devices as well. And also user ID, you said, right? Most of the ads which you see, right, you don't really need to log in, right? Okay, so I mean, any system that you talk about, right, there are multiple websites without even, I mean, you don't really want to want the user to be logged in for him to see the ads, isn't it? So that means we can't
I think, Pratik, I think along with the RID, right, there will be some other ID has to be sent by the advertisers. So in that approach, right, even that end user try to, fuzzy that particular link, he won't get that particular, different ID. So then only we can maintain the, consistency and serve as an idempotency key.
yes, okay, so correct. What Samal said is right. Let's say every ad placement, right, has a unique ID. Okay, so this way we don't really need user ID, right? And that ad can be I can click that ad from multiple devices, from multiple browsers, right? Correct. If there is a different ad ID, right? So that means what if same, no, sorry, not, I won't call that as ad ID. What can I say that? Mm,
Usually we said impression ID as a overall system, but you can take that one any ID, no problem.
let's call that what do you call? I'm not really getting a name to it. Let's say some generated ID. Okay, let's say we call that as X. Okay, so that means what every ad has a X in it. Okay, X ID, which is not actually the ad ID. So that means what two. So an ad ID one, right, an ad ID one, if it is shown on two placements, right, it would be, let's say, ad ID one, which will be X, and a unique ID for it would be X1. And if that same ID is being shown somewhere else, right, so it would have a different ID, let's say X2. Okay, okay, or you can, or let's call this as an impression ID, right? I think Shamal said, right? So let's call this as an impression ID. Okay, let's call this as an impression ID. That means what, wherever that ad is getting we are seeing that ad, right? we have some impression ID associated with it, right? Okay, so now the ad processor gets one ad with the same impression ID. I'll say, okay, this is a duplicate one. I'll reject that. Correct? I'll reject that. But let's say a hacker is there, right? And if he just changes, let's say whatever the ad that is shown to him, right? He goes to the developer console and and he he picks up that impression ID and changes couple of digits in it, right? So what would happen is the ad processor would actually get multiple clicks on this, right? Because they all will be unique.
You have added non-functional requirement, probably no spam detection, right? So leave that part. The spam detection is not part of the system.
No, this is idempotency only. I'm talking about idempotency only, right?
Yeah.
Correct. So, anyways, I mean, let's say if it is a little late, right? So we can skip that, but understand that there has to be something, right? This ad processor has to check, right? And that impression ID should be generated somewhere from here itself, so that when that ad comes in, right? When the click comes in, it is able to validate that yes, this is a valid impression. This is a valid impression. This is a valid click. Yeah.
So in case of a user is not logged in, right? How we will manage that?
No, any ad that is placed, any ad that is shown, right? Once this client, let's say comes up, right? Let's say browser, right? Once he opens that page, right? That ad, he will ask this ad service to give me one ad, right? Now this ad service will generate an impression ID and embed that into that ad placement.
No, my question is the client is not logged in actually.
Yes, the client is not logged in, but the browser has asked for it, right? So there is an impression ID associated with that ad placement.
But again, it will be duplicate, right?
Why? See, this is one client one, right? There is another client two, right? So this is asked for an ad, right? So what happens is this ad service, the same ad ID one, right? It will say impression ID one, it will send, right? And to this it will say ad ID one, impression ID two.
No, this is valid only when the user is login, correct, Pratik? It's very clear, right?
Where is user getting login? There is a request that this client is making a request. I am opening this page. Show I want there is an ad to be shown. Where is user associated with it? It's just a random ID which the ad service has generated.
That's fine. So
if you don't associate with a user, then this system can be hacked, right?
Yeah, absolutely.
Why?
So you got a ad ID and impression ID, right? In a client. Client has not logged in at all.
Correct.
So then what is your thought?
The thought is that every ad that is shown, there is a unique ID associated again. That this is the impression ID one, this is impression ID two, right? So now what happens is, let's say if he clicks on this, right? Now ad processor knows that okay, this ad ID one was clicked with an impression ID one. Where is the
Okay.
No, but then how it is tied up to the users? I mean, this impression ID.
It's not with the users. I don't care who has clicked on that ad. I want to know as an advertiser how many clicks did I get.
That's the point actually. So when we click on an ad, the advertiser or the server, right, like Google Ads or Amazon, they don't care like if you are logged in or not. You just clicked on the ad, right? That's the business.
Yeah.
No, that is very clear. It is understandable. But how you will give a accurate information to the advertisers, the capture of the events, because we are capturing only the number of clicks, not based on the user.
Yeah. How do, as an advertiser, I'm only interested in,
No,
right?
it will get false, Pratik. It will get false. I think so.
There should be a justification. Just justify me. Tell me, please.
Just one case I can think of. Suppose I opened a browser, I clicked on an ad. I refreshed the browser. I clicked the ad. So there are now two impression IDs, right? So
Correct.
that's
Yes, right.
So those are two different clicks, right? I can actually open that ad from here, and then I can open that ad from somewhere else as well.
now it's a clarification that advertiser has to provide, because as a mobile farming, right, I can have consistently refreshing the browser, ads getting loaded, clicking on that.
Correct. So now listen, now understand this as well, right? Now when this ad service is just not serving this ad only, right? It is this ad service will not always give ad one only, right? It will give other ads as well, right? And it may happen that I opened this and I found the same ad in this tab, and I opened again, and after some time also I can see the same ad again. What's the problem? That's a genuine click, right?
After some time it's fine, but there is a worst case, right? That the same ad gets loaded.
Correct, but that's the ad service who's actually pushing this, right? If they are pushing the same ad, right, to this
So
client.
my point is, or probably if everyone buys in, so using impression ID is good, but apart from that, if we can associate some sort of sticky ID to it, right? Like maybe from the cookie of the user or the browser, some sort of identification.
Correct, that is valid. We can, right? But I mean, there's no harm, right? So
No, I think that is how I'm not sure. Like this YouTube and the real time Google ads and all, right? AdWords and all, right? That is how they are tracking actually. Because the paramount of the system is to provide the accuracy to our advertisers based on the advertisement they have published, right? We cannot compromise the system on that context.
again, are you able to see my this thing, right? Okay, okay. Just open your Chrome browser, right? Okay, open your Chrome browser, right? In incognito mode, open YouTube, okay, and you would see the ads getting played on that YouTube video as well. You are not logged into it. So yes, you can restrict it, right? If you really want to know who are the users clicked. So this is situation to situation basis, right? Open your Chrome browser, right? I think you guys are not able to see my window there, right? Open your Chrome browser, open in incognito mode. You're not signed in, right? Open any video, right? You would see the ad first playing on it. The user is not logged in.
That's a very business specific scenario. Yeah.
Correct. Now, one important thing. If you want the user to be logged in, right, that means you want to retarget that user, right? In that particular case, yes, the user should be logged in. So now let's say there is some. Now this is what the user retargeting happens, right? So now let's say if you're not logged in, I won't really know who really clicked that, but somebody clicked, somebody was interested in that product. This is what it means, right? But if I get the user ID as well, I can retarget that ad, right? Somebody who bought a bed sheet, right? And if I know the user ID of it, I can have my system to retarget to buy to show him ads for the pillows as well. This is the retargeting. Yeah. Cool, guys. I think we should end the discussion now. But hope any questions, anything. If you want me to summarize, this is a very good practice.
Yeah, we need to find multiple clicks on the same ad by the same user, right? Should not result into multiple clicks. That is our goal, correct?
Yeah. Okay. I probably I did not cover the idempotency thing, but you guys can.
Yeah, sure. No problem.
But anyways, I'll just summarize quickly. One very important thing is that I realize, again, I'm repeating this. Always summarize your interview, always summarize your diagrams, because you get your feedback after 2 to 3 days, and it is always easy for the interviewer to say a no rather than saying a yes. Okay, so now this leaves an impression on the interviewer. Okay, so now basically what we discussed about here is that advertiser would push the ads to this ads DB, right? And this ad service would be serving the ads to the client, right? Client would go to the ad processor, right? Sorry, client would click, and this clicks would reach to the ad processor service, right? This would be pushed to the Kinesis, right? Kinesis would actually read the clicks, compute them, right? In an aggregation window of 60 seconds, and then push them to the OLAP DB, right? We also will have another path for the batching, where through Kinesis we'll have some kind of a consumer service, right? Consumer service which will consume the raw clicks and dump them into S3. Then this Spark job would be there, which would be initiated by a cron, right? And this would compute on this S3 data and then push them to this OLAP DB. And this reconciliation job or a service, right, would compare the values for that particular minute and then make the changes to it, right? So this is a whole overall high level thing. Again, very important, the data pipeline, it has 5 steps, which is collect data, ingest data, compute, store, and consume. Okay, we also discussed about Kappa and Lambda architecture. I forgot to mention why is it named Kappa, right? Because these names are picked up from Greek, right? So Lambda is represented, you guys all know, right? Lambda is represented something like this, right? Now, this is basically the next character in Greek. So that is the reason they said like, okay, after Lambda, we'll say this Kappa. That's the only history about it. Okay. So this is a funny story about their naming. Okay. So in Lambda architecture, they have the batch layer and they have batch pipeline, and there's another pipeline which is the speed pipeline. And in Kappa architecture, you only have the speed layer, which is targeted for the low latency. And in Lambda, you want to basically achieve accuracy. So that's why you have two flows running together. Okay. So,
I was thinking, right? So to avoid the deduplicate, right? All of us are discussing, right?
I just
So
want to just quickly complete
go
this.
ahead, go ahead, go ahead. Yeah.
Okay. So anything else that we missed, guys? Yeah. Otherwise, we'll just stop the recording. Thank you.
Yeah. So what I want to add, right? We all are discussing